Hey guys, I'm Roman. I'm a machine learning researcher, and today I'm going to talk about why prompt engineering and context engineering are actually a very difficult skill, and they are the number one skill of the future going into the next decade. The current misconception that people normally have is that prompt engineering is a lower skill ceiling and skill floor than typical traditional coding, and by quite a bit. People are saying that the skill economy behind engineering in general is either dead, or they're saying that large language models are incapable of writing good code. I vehemently disagree with both of those points. Let me start off by talking about vibe coding. Vibe coding is defined as going with the vibes while developing an application. It's basically going with what feels good, turning your brain off. Engineering is defined as dedicated planning for logical architecture. The idea of calling vibe coding engineering is a complete misnomer. There's a new discipline, and I call it agentic engineering. And agentic engineering is effectively prompt engineering mixed with context engineering, mixed with agentic harnesses. Quality is suffering. Here's the skill reality. The skill required to get started with vibe coding is very, very low. Anyone can get started, technical or non-technical. And vibe coding is a very rewarding discipline at first. And then you run into vibe debugging, which takes out a lot of time from people's day and sours them on the idea that large language models are a good tool for speeding up development. I'm sure you've all heard the studies that are saying that developers now are building applications at a much lower speed than they were before LLM coding, due to how much time they are spending on debugging model. This is what happens when we're not mature enough to keep our engineering wits about us and to properly guide the model to the mental picture that we have of the perfect output. In the current state of the models, there is no doubt that this is a skill issue, because the models are good enough to do pretty much anything if you give them the right prompts and the right context. The only things that are separate from that are what we call hallucinations or context rot, which both of those are primarily a skill issue. Now, hallucinations are baked into the model architecture and will always be present. But through agentic engineering, there are plenty of ways to mitigate that. So let's talk about the skill ceiling now. The skill ceiling for vibe coding and how much skill is required to fully master it and get it to the optimal development level is very low. It's meant to be relaxing and feel productive. Now, agentic coding, on the other hand, is a very, very high skill endeavor. I would argue even higher skill than traditional coding. Now, the reason for this is that traditional coding is actually a subset of agentic coding. So if you are agentic coding at the absolute highest level, you are describing the exact syntax and architecture that you normally would through code, which means that at very least they take the same amount of skill. But now you have to deal with dodging model hallucinations, orchestrating teams of agents, and understanding what models do and do not like. And you have to understand different softwares and different harnesses. Not only this, there's a meta skill, which is the skill of developing at a quicker speed. So agentic coding is model behavior, context engineering, and orchestration together, where traditional is just. So I'm going to real quick talk about why vibe coding is a very dangerous discipline to get into. and it's detailed manner. So let me talk about the optimization landscape here, which is a game where the x-axis is the time spent on the application or working on the build, and the y-axis is going to be the quality of the output. So in traditional coding, you are going to get a very quality output, but you end up spending a ton of time on it. This is not a terrible thing to have happen. Vibe coding, obviously, is just going with the vibes, no thoughts in your mind. It's pretty quick to get something working, but the quality actually turns out to be complete garbage and is never going to be up to production standard. And we have seen many examples of this. So let's talk about prompt engineering now. This takes about a fifth of the time as traditional coding, and I like to call it the optimal middle ground. It is shifted above that line between vibe coding and traditional coding because you're learning how to properly describe the picture you have in your mind to the model and get it to exactly where you want. Now, this actually should take more time than a lot of people spend on it. If you are just writing exactly what you want the model to do, with actually thinking about the ramifications of what's going on, you are just vibe coding. So prompt engineering takes a lot more brain power and a lot more work. This is a skill that's learned over time. Actually, knowing how to traditionally code scales your ability to prompt engineer by a huge amount, or programmers. So there is a new game that we're playing, but knowing how to engineer is part of the battle. So there's an even better version of this, or most people call context engineering, which is basically where you are trying to optimize what context is going into the model so that it does not get rotted with context. So agentic coding is the benefits of the context. So agentic coding has the benefits of the context engineering shift. Also means that you can automate some of the parts of prompt engineering. So if you save prompts or you have system prompts that go to agents, like for example, if you have a coding agent that you call your Docker agent, which has access to the most recent Docker documentation, this is going to be faster and better than prompt engineering. So agentic coding is actually very useful. That goes on in it. So if you're asking a model, build me a dashboard, the model is going to have a lot of questions in its mind of what you're talking about. First and foremost, think of the question the model has, which is, what industry are you talking about? So there's, a bunch of industries that the model could be speaking of. There's a bunch of industries that you could be speaking of. In this example, we're going to say finance, healthcare, or SaaS. Now there's another. So in this example, it's going to be finance, healthcare, or SaaS. Now, what a model is, it will either flip a coin between the three if it has a little bit of relevant information where it can figure out that one of them is more likely to please you than the other. Or what it does if it has absolutely no context is it will blend them together into AI slop garbage. So you will just get jargon from and the reason is because the models are rewarded to be unoffensive, a dangerous road. And what you end up seeing a lot of times actually is if you are talking to a model and you give it a not nice prompt and you look in the model's thinking window, it will actually very commonly be like, I'm not sure whether the user is asking for, A or B. I'm going to pick A because ... So model actually expresses this confusion in its thinking window, but it's so sycophantic, which means it wants to please you, decides to ask a question. So this happens again, iteratively, and you get slop on top of slop on top of slop. Now, when people say they're getting AI slop and they don't trust AI to code, this is what is happening. What happens when you're vague? You get no color specified. Ever see the blue-purple gradient? Yep, this is the training data median that the model saw that it liked. And the reinforcement learning in the model's architecture, the reinforcement learning step guided it towards choosing blue and purple gradients as a default whenever it's not specified. So here's another example. No images specified, or not enough material to actually make the website look aesthetic, it's going to generate generic SVG icons absolutely everywhere. Is there no copy direction? Well, you're going to get the not only X, but Y, or it's not X, but Y. This is a very common repeated pattern in its training data, which happens as a result of the reinforcement learning. M dashes everywhere. That's what happens when the model is not given enough context and not enough voice or tone, and it's not given a proper role. So all three of those things are kind of what normal people would assume are default model behavior, and there's no way to get rid of them. There is absolutely a way to these phenomena, and it's called proper prompt engineering. So when you're very clear on the color palette, you are not going to get these slop gradients. When you're very clear and you fill up the UI with enough images or details or clarity on what SVG icons to use where, you are not going to get these slop SVG icons. If your copy is strong and you give the model a voice, you give it tone, you give it quotes, you give it examples, it is not going to do this as often. Now, I'm not saying that it's never going to do this, but it's not going to do this nearly as often. Let's talk about the same tree from before, but with specificity. So, if you're very clear in your prompt that you want a SAS dashboard, and you want a dark color layout, and you want a sidebar layout, you are going to get these. The model typically, unless if you've overloaded it with context and you've not context engineered properly, is going to listen to these directions if you're very clear with it. So here's the real stack for agentic coding. First, you have to have a very clear mental picture of what you want. For a UI example, which is the easiest, if you don't know exactly how a UI that would blow your socks off would look, then you have not mastered the clear mental picture, and you cannot be upset when you get an improper UI that looks garbage. So this is why giving the model direct images, using Figma for yourself, sketching it yourself, really thinking about it to get that mental picture is very important, and it's the most important skill. Secondly, natural language translation. So if you have this clear mental picture in your mind and it's as crisp as it can be, or you have a Figma diagram that's as crisp as it can be, knowing how to iterate this to the model is incredibly important. And it's almost like its own syntax. The model has defaults that it knows and things that it doesn't know. You learn the model's behavior speak mental pictures into reality using the large language model as a medium. So number 3, most important, is going to be domain knowledge, which is crucial for not only the mental picture, but the natural language translation and debugging down the line. So if you are an expert in the domain we're trying to build, like you are a video editor building a video editing app for models, then you know what looks right and what looks wrong. There is a lot of bad training data in these models that is going to have it output generic, incorrect application features. So if you know exactly your domain and you know what is good in the video editing space to include in an app, then you will get that if you can properly indicate that to the model through natural language translation. Let's talk about engineering concepts. This is the 4th most important. You transfer to agentic engineering from traditional coding and software engineering. If you know all of the principles of traditional coding and software engineering, you have a big leg up on everyone else. If you don't come from a technical background, you can still learn this stuff. Very important. So, understanding model behavior and prompt techniques is a very crucial part of the stack as well. I have built something that actually helps with this. And the way that this works is you press a keybind on your keyboard. Then you have a submodel ask you a bunch of questions about the initial prompt you gave. And then once you answer those questions in a detailed manner, the agent in this application will give you a very clear and thought out prompt without you having to type out XML tags, chain of thought, roles, stuff like that. So this all happens automatically in this application that I built. And based on the architecture, you can obviously build it yourself too. But if you don't want to worry about building it, you can hit the link in my description to join my free school community. So you can build techniques yourself using this type of software. Now we're going to talk about context engineering, which is very important as well. And this is understanding what is the minimum amount of context that will get the best possible output from a given prompt to a large language model. So context engineering effectively comes down to compaction, handoff documents, not oversharing things that are useless, and trying not to rot the model with context or fill up the model's context window. If you guys use Claude Code and you guys have the max where you can use Opus 4.5 in Claude Code, you would know that after a 5 to 10 minute conversation, the model's context window literally fills up and has to compact. This compacting, if not done at the right time, or if not prevented properly, decreases the output of models in different studies by up to 60 to 80%. Now, tool knowledge basically means understanding what tools are out there and what tools to give to the model and stuff like that. A tool would be Claude Code. So understanding how to use Claude Code is another very important skill. And iteration, debugging, and guardrailing are other skills that are important, particularly in RAG agents. And RAG agents, guardrailing is unbelievably important. If you have an agent for a business app that is able to leak various details about your business or your system prompt, you are in trouble. And you will not be able to have a production application with this RAG agent. And iteration and debugging are just learned over time. So code reading, I want to clarify, is not required, but it can be very nice for production applications to be able to skim through or read very quickly a large chunk of code that was output entirely by a large language model. Because once again, models do hallucinate. You want to spend about 90% prompting and about 10% reading your code that the model output and verifying that it's okay. So there's a meta skill that I mentioned earlier, which is speed optimization. And it's basically the fact that we have these models which can 10x our output gives us a lot of power, but a lot of responsibility. And knowing how to iterate quickly without loading features onto your apps, under engineering or over engineering, is very crucial because now we can build at a very fast speed. Applications quickly. So in your prompts, for example, if you over design, that can lead to context rot. So if your prompts are 100,000 tokens long of very detailed specification for your app, then you are over designing. And you have now gotten the model to a place where it's confused and tends to ignore the middle of your prompt, which if you are a coder, your next coding session, the following. Go ahead and take an algorithm that is very important to you or that you know like the back of your hand and try to implement into your model's context window. Literally type algorithm. So, right now I'm going to share with you So here's a little homework for you if you are a traditional coder. What I would like you to do is take this example and apply it to an algorithm that you know very well. So in this example, I have an algorithm for pooling that is very common. And this is basically max pooling, which will slide a window over your data matrix and take the maximum one from each window. This is useful because it's a way to compress expensive data, and it's a very common algorithm. So what I would like you to do is take your algorithm and tell Claude Code or whatever coding model to replicate it exactly and literally copy paste the code to them. This will give you the exact code, typically. The exact code that you gave to the model will be provided by the model with no changes. Now think about this. Try to take the same level of detail you spent coding and write it in plain English to the model. This is going to feel unnatural at first, but this is going to provide a breakthrough to you once you realize that the model output the same exact algorithm that you gave it originally. Maybe slightly different, but it should be the same in terms of the actual logic the model output. Belief I want you to destroy is that the model can't code your algorithm, because it can. It's just that in the past you didn't give it ample instructions that are detailed enough. So in this case, I described in very plain English exactly what the algorithm is and how to code it and what it does. Now, I would like you to repeat this exercise and each time try to get the same algorithm out of the model while adding a layer of abstraction. So minimizing the number of characters of input you gave the model. This is a very difficult thing to master because it takes understanding how the model will react to your prompts, what the model should include and shouldn't include, and understanding deep knowledge of the algorithm itself. So this is a very nice example of why prompt engineering is a very skilled discipline. Because prompt engineering, if done more and more detailed, to try to get the model coding. So if you're not a coder, based on watching this lecture, is I would like you to stop vibe coding. Spend 5 times to 10 times the amount of time and 100 times the amount of brain power and effort in each. So I wanted to end this lecture by saying that engineering is not ending. We are just beginning a new frontier. The game is changing. The way the game that used to exist is played is very different now. And if you do not get in on it, you are going to drown. But if you do get in on it and you understand how to prompt models and how to code with models and build and develop, then your output will be faster than anyone else's and higher quality. And people will be asking you how you are getting so much quality output out of these models. But my one takeaway for you is that the models are good enough to do the same level of engineering that you're doing. It's just that you need to change and reframe how you are doing the engineering and what you are spending your time on. Clear mental picture, architecture, and agentic orchestration is the new key. Syntax should no longer exist in your mind. Rules. Join my Skool community. It's free.